It's the last Tuesday. It's a 5. 18, 21. And we are going to do the final review. For the test. Okay, let me just bring the final review for myself. Okay, this is it. So we have some topics from the earlier part. So what I'm going to do, I'm going to do the second part first, especially those things about triangles. So we got quite a lot of questions over there. Okay, so I take it from, I go from number 6. I explain this first. Okay, 6 up to the to the 16 because you are fresh now. Then we get back and we finish the other part. Okay, so we start with number 16. We give you one of this equation that you did it before. So I just put one as a, okay, as a sample. As a sample, this is number 6. Number 6, you want to solve this equation. It's one of the question I think in test 3. And the equation is 2 cosine of x plus radical 3 equal to the 0. Remember, we did it with the sine, with the tangent, and with the cosine. So this is just one sample. So this means one of these types would be given to you. And they ask you to get the, in particular, the solution between, okay, we are interested in the particular solution between 0 and 2 pi. You know that you are going to isolate the cosine in this case. It's going to be 2 cosine x equal to the negative radical 3. So the cosine x would be negative radical 3 over 2. You go to the table and quickly you find it. Okay, so radical 3/2, if you like, this can be, so, you know, we can find it quickly. And the cosine is negative, so we are going to be either on the second one or on the third one. Okay, radical 3/2 is going to be the cosine of the 30 degrees. Okay, so it's the 30 degrees. So you have one over here. It's going to be 150 minus 30, and the other one is going to be here, which is going to be 30 plus pi. So the solution are going to be x equal to the 5 pi 6, which is going to be 150. And the other solution is going to be, okay, this is 210, which is going to be 7 pi 6, and you are done. Okay, any question? So this is the most that you need in future, really. But this is cosine. We may give you sine, tangent, secant. Just, you know, check the one that you did for the on the test 3. Any question? Number 7, this is, they give one famous, you know, quadratic equation. So I just put over here 1 so that you know that one of these quadratic would be given to you. It can be quadratic in terms of the sine, cosine. You may have to change it as we did it before. So in this case, the problem is a 2 sine square of x minus 3 sine x plus 1 equal to the 0. And we did this one before. So you don't need to change anything. It's in terms of the sign. You can factor it if you can, or you can use quadratic formula. This one is factorable. So it's going to be something like sine x minus 1, okay, times 2 sine x, okay. And this is going to be 2 sine x minus 1 again. Because if you multiply these two together, you get a positive 2 over here, and this is 2 sine s squared. And be prepared, you know, to get it by using the quadratic formula, whichever you feel more comfortable to be able to do it. So if you go with this, right, this is going to be sine x equal to the 1 from the first one, and the sine x equal to the 1/2 from the second one. From the first one, you want an angle whose sine is equal to 1, you know that that angle is going to be x equal to the pi half. We get one solution. You want an angle whose sine is going to be 1/2. So this is going to be the sine of the 30 degrees on the first quadrant. And you get another one in the second one, which is going to be 5/6. So the solutions are going to be x equal to the pi 6, pi half, and the 5/6, and you're done. Okay, so check all the quadratic one that we did on your test 3, quiz 3. We did quite a lot. Sometimes, remember, there was a cosine and the sine together, then you have to change them, just be prepared for it, for one quadratic. Okay, that's a 7. Any question? Number 8. There's something else, something special about this number. We are going to give you one to find those complex roots of a complex numbers, okay, and one to solve the equation. The complex root would be a complex root of a complex numbers, not just a real number. Okay, so in this case, you want to find the third root, okay, find all the complex root, okay. The third root of a number is 4 minus 4 radical 3i. Okay, we already talked about the formula. We have to change it to the polar form, and we have the third root formula, and we substitute to get the result. So change it to the polar form first. So that would be the solution. So you have to carefully change it. This is going to be z equal to the 4 minus 4 radical 3i. You call it x plus iy. Okay, so x is equal to 4, compare it. Y is equal to the negative 4 radical 3. So we're going to locate the point, locate the numbers. So x positive and the y negative. So you are going to be here. You know that that would be important when you want to pick the data. So we go for r. R is equal to the square root of x squared is 16 plus 4 radical 3 squared, y squared. 4 squared would be 16. 16 times 3 would be 48. So that gives you a square root of 64, which is equal to the 8. So r is equal to 8. Okay, any question? Get the tan of data. Tan of data would be y over x. So in this case, you have negative 4 radical 3 over 4. The result is negative radical 3. Okay, for the negative radical 3, you have to pick the correct data that we're going to have. So this was x positive by yeah. So the data that we're going to pick, you see the radical 3. Radical 3 is going to be the tangent of the 60 degrees. Okay, just tangent of the 60 degrees. So 60 degrees is over here. You have to come to the to this fourth quadrant if you like. Okay, so in this case, your data is going to be what? Is going to be 300s because this is 60 degrees. Okay, to get the 300 over here. So the data is going to be 5 by 3rd. Okay, this is going to be the case that we are going to have for the numbers. Okay, any question? So we get the x and the y, we identify it. Okay, and then we would be careful to see where we're going to get the that numbers, but you got to be careful over here because the tangent can be negative. The tangent can be negative in the second quadrant over here if your point is going to be on the second quadrant, or the tangent can be negative over here. But the point is, okay, the point is 4 and -4 radical 3. So this is going to be the case that you're going to have. So you have to take the theta to be 5 pi third. Okay, any question? Now we can check the, the third root. So what's going to be the third root? So this is going to be z to the 1/3, if you like. Okay, so remember the formula, it's 4 minus, we call it z. So this is going to be r to the, r is 8, 8 to the 1/3. Okay, 8 to the 1/3 cosine. Cosine of what? Cosine of theta. Okay, the theta is 5 pi third. Is going to be 5 pi third plus 2k pi. 2k pi divided by n, which is 3, plus, okay, plus I sine of 5 pi third, again, plus 2k pi over 3. You've been asked to leave the solution in the polar form, but you have to simplify it. So this is going to be where k is equal to the 0, 1, and 2 to get your 3 solutions. Okay, you can simplify it a little bit. You can get rid of these 3 by multiplying the top and the bottom by 3. And this is 8 to the 1/3, which is going to be equal to the 2. So we can rewrite it as a z to the 1/3 is going to be equal to the 2 times cosine of, I multiply the top and the bottom by 3, so that make it to the 5 pi plus 6k pi. Okay, 6k pi plus 9, and this is going to be plus I sine of, okay, the sine of the 5 pi, again, plus 6k pi divided by 9. Okay, any question? K equal to the 0, 1, and 2. Now you have to identify those 3 solutions for us. Since you see, look at this one. Since the number is a complex numbers, so this means that the solutions are going to be complex numbers. So you cannot use that idea of the conjugate that we talk about it. You see, if this is going to be a number, a real number, then that conjugate would happen. In this case, you have to identify all the solutions, 3 solutions. K equal to the 0 first. K equal to the 0, that gives you z1. Okay, the z1 would be 2 times a cosine of. K equal to the 0, that gives you 5 pi 9. Okay, 5 pi 9 plus I sine of 5 pi 9. Okay, you cannot simplify it. And the 5 pi 9 is not a popular, popular angle, because pi 9, you know that it's going to be 25 times 20 would be 100. So you're not going to have an exact number for this one. So this would be the final answer. If this angle is one of the one that is on the unit circle, then you can, you can change it. But otherwise, this is going to be the first solution. Okay, any question? You cannot use the idea of the conjugate because your number is a complex numbers. So you have to go on and find the 3 solution. So k equal to 1. If you put k equal to 1, so your z2 would be equal to the 2 times the cosine of k equal to 1. If you put k equal to the 1, that gives you 6 pi and 5 pi. 6, 5, and 5 pi would be 11 pi 9. 11 pi 9 plus I sine of 11 pi 9. Okay, you can simplify it if you like, but we cannot find the exact number because 11 pi 9 is pi plus pi 9. And the cosine, if you like, you can simplify it, but you don't have to. You can, just give you the idea of this is going to be equal to the, you see, it's going to be z1 equal to the 2 times the cosine of, you see, 11 pi 9. 11 pi 9 is the same as the, okay, it's the same as the 2 pi 9. Okay, that gives you 11. You don't have to, but if you like, this is cosine of the pi plus 2 pi 9 is going to be negative, and then you can change it if you like, but otherwise you can leave it just for one option. If you like, this is going to be negative cosine of the 2 pi 9, and the sine is going to be the same thing, minus I sine of 2 pi 9, but you don't have to. But write it down in this format, we accept it, because this number, there is no exact value for it. And you have to go on to get the third one. So k equal to 3 is going to be equal to the z3. Z3 is going to be 2 times cosine of. If you put k equal to 3 here, you see 3 here, 3 times 6 would be 18. Okay, would be 18, 18, and 5 would be 23. So that gives you the cosine of 23 pi 9 plus I sine of.
Professor, is it k equals 2?
Oh, I missed it. Sorry. Thank you.
Yes.
I find that number so unfamiliar. Thank you. So what's going to be the result? 2 times 6 would be 12. That gives you 17. Yes, that's 1. That was 5 pi. So that gives us 17. 17 pi 9 plus I sine of 17 pi 9. Okay. Again, you don't have to, but 17 is 18 minus 1. So we can break it. You see, you can break it into the cosine of 2 pi minus pi 9. And then you can write it down, in the easier form if you like. But again, you don't have to. You see, 17 pi 9 is like what? Is like 2 pi minus pi 9. Yes, 9 times 2, yes. You see? Then these 2 pi would be disappeared, and then you can write it down in a shorter form. But these are just options that you have. If you like, you can simplify it. So this is going to be like, is going to be 2 times a negative cosine of the pi 9. Okay, and because the cosine 2 pi minus alpha or 2 pi minus 20, this is, okay, this is 360, this is 340. So the cosine, in fact, is positive, and the sine is a negative. That gives you sine of the pi 9. Okay, these are optional, but I just did it so that you know that all the 3 solutions are different. So don't go for the conjugate. Find all the 3 solutions. If you have an equation that the coefficient in that equation are all real numbers, then you can do that. Z4 plus 1 equal to the 0, finding the 5th root of z to the 5th equal to 1, those type of numbers. But if the number is a complex numbers, make sure that you know that you see if the numbers that are going to take the root is the complex numbers, 4 minus 4 radical 3i. Remember, you have to give us 3 solutions, and we write it on in this form. You don't have to use your calculator, but simplify it and give us the final answer. Okay, any question? So we give you 2 questions on these roots. This is one of them that we would like the number to be complex, so that you have to write these for us. Okay, the angles may not be a nice one, but it doesn't matter because you are not going to do anything about it. But we give you another question. The other question would be directly solving an equation, an easy equation that you have to use these roots again. Okay, any question? And that's question number 9. So in one question directly we ask for the third root, the 5th root. These are going to be the candidates. But in the other question, we ask you to solve the equation. So in this question, they ask you find all complex. You see all complex and real solutions. So this is an equation that you have to solve. Okay, complex and real solutions of this equation. The equation is z to the fourth plus 16 equal to the 0. You see, there is no complex numbers here. So in order to identify the roots, you can use the idea that if you find one complex solution, then the conjugate would be also the second solution of your equation for this one. Okay, are you ready? You know that. You are going to move the 16 to the other side. So for the solution, we solve for z first. Z to the fourth equal to the negative 16. Okay, so z is equal to negative 16 to a quarter. So this means you are going to find the fourth roots, the complex roots. The complex root of the negative 16. You know that if you have to change the negative 16 into the complex form or the polar form. So your z is going to be equal to the negative 16. And you know that for negative 16, x is equal to the negative 16, y is equal to the 0. And that would be helpful to know that this is going to be your point. Okay, and you know that this is going to be the angle in question, which is pi. If it's going to be positive 16, you're going to take it to be 0. If it's going to be negative number, naturally it's a pi. So your r would be the same thing. R is, because the y is 0, so the r would be 16 squared, 256, which is the same as a positive 16, okay? So it's a 256 plus 0. So the square root of 256, which is 60. So the r is equal to 16, and tangent of the theta automatically, you know that it's going to be pi. If you go with the formula, and that give you the 0. So you know that tangent of the 0 is 0, and tangent of y is 0, 2. But since the point is here, we know that the angle in between must be pi. Okay, any question? So we got the r and the pi, and we need the fourth root. So there you are, negative z equal to the negative 16 to a quarter is going to be equal to the r is equal to the 16. Okay, 16 to a quarter, 16 to a quarter, and CIS of pi bat is going to be cosine of the pi plus 2k pi. You want the fourth root divided by 4 plus I sine of pi plus 2k pi divided by 4. Okay, and you know that you need 4 solutions. So k equal to the 0, 1, 2, and 3 to get the solution. Now you have to list the solution. And if it's something on the table, you have to give us the numbers. Any question? So we put the k equal to the 0 to get the first one. If you put k equal to 0, that gives you CIS of the pi 4, and 16 to a quarter is equal to 2. So put the k equal to the 0 for the first solution. So if k equal to the 0, so the first solution would be z1 is equal to the 16 to the quarter would be 2, and that's CIS of pi 4. So the cosine of the pi 4 plus I sine of the pi 4. Since it's a familiar one, we are going to use the table and give us a, don't use your calculator. It must be exact value. Okay, cosine of the pi 4 is a radical 2 over 2, and this is going to be plus I radical 2 over 2. Okay, multiply the 2 inside. So the z1 is going to be radical 2 plus radical 2I, if you like. Okay. So this is going to be the first solution. Any question? Since we are taking the complex root of real number, so the conjugate is going to be the second one. So the conjugate is radical 2 minus radical 2I. So that gives you 2 solutions. Any question? So if the original number was a complex number, remember, you cannot use the idea of the conjugate. It's going to be real number, we can do it. So let's say k equal to the 0. We need 2 more. So we go with the k equal to 1. We get the z3, this is going to be 2. Okay, if you put k equal to 1, so that give you 3 by 4. So it's going to be 2 CIS of 3 by 4, cosine of 3 by 4 plus I sine of 3 by 4. 3 by 435 in the second quadrant. So it's going to be 2. The cosine is negative radical 2 over 2. And this is going to be plus I. The sign is stay the same. Okay, multiply the 2 inside. So that give you negative radical 2. Okay, plus radical 2i. That's going to be the third solution. And the conjugate of this number, z4, which is going to be negative radical 2 minus radical 2i, is going to be the fourth solution. Any question? So the degree of the equation was 4. You should have 4 solutions. And all the solutions are complex numbers. Originally, we deal with the real equation. There was no complex numbers to start with, so we can use the idea of the conjugate to get these numbers down. Okay, any question? So 2 questions, very important one for future application really of these sections. So that was number 8 and the 9. And number 10 is one of those equations that the angle was different. We did this one before. Again, it can come with the sine, cosine, and the tangent. So this is a tangent one. You want to solve this equation. The equation is tangent of 2x minus 1 equal to 0. We did it in one of those previous tests. Okay, and of course they asked the solution between x and 2 pi. I think it was question number, one of the question in test 3, I think that was the one. Okay, we are going to isolate the tangent first and then we take care of it. The angle is 2x, we can do it. So, and this is it. The solution would be, we have the tan of the 2x equal to 1. Okay, we know that the 1 is going to be tangent of the pi 4. Okay, so 2x is equal to the, so 2x is equal to the pi 4. Okay, this is going to be one of the solution, but the tangent of x equal to the 1, tangent is going to be positive in the first quadrant and the third one. Let's take this one first. You have to divide by 2 to get the x. So x would be pi 8. Okay, so this is a solution from when we take the angle to be equal to the pi 4. But for the tangent, we know that tangent is also positive in the third quadrant. So the third one would be 180 pi plus pi 4. So you have another solution, 2x equal to the, okay, 5 by 4. Okay, 5 by 4. And over here, you find the x. So you have to divide by 2. So the other solution would be 5 by 8. Okay, so we get the first solution for this one, a tangent of 2x equal to 1. Okay, in this case, that give you the first solution for the tangent to be positive, and the second solution would be 5 by 4. So we put them together. So the solutions that you are going to have are going to be pi 8 and the 5 by 8. So the one we are interested in to get these numbers. Okay, any question? So, just check your lecture notes. Check it that we did have it with the sine, we have it with the cosine, or we have it with the tangent. They call it, equation containing the multiple angle. Multiple angle means 2x, okay? It's not just x. So double check it. Make sure you are not going to be surprised when you see it. Now, this is number 10. Any question? Now we go to this new part that we did for the triangle. We give you something like 3-4 questions on this one. So don't miss it. It's not difficult, but be patient. Make sure you get it right. So start from number 11 and we end up in number 15. So it's a kind of 4 or 5 questions. Remember, when you want to solve a triangle, means finding the sides, the length side length, and the angles. And we give you something like I think it was something like 5 different cases. So you will get 1 question from each. Okay, so you have to know the law of the sine, okay, and the law of the cosine. And we give 1 problem to find the area problem. Okay, so we start with number 11 to see what is this one. So this is number 11. You want to solve the triangle. Okay, that's it. From now on, you want to solve the triangle. Okay, and solve the triangle. The first one is angle A is given to you, is 122 degrees. Then the side B is equal to the 11. The unit, if they give you the unit, otherwise there is no unit, so it doesn't matter. And the A is equal to the 23. You can call it, inches if you like. So this is the information that we have, and we want to solve the triangle. Okay, so get a graph of a triangle, put this information on it. So you have to have a triangle to see how we're going to operate those formulas. Okay, it's going to be A, B, and C. Okay, in this case, what we have is, that the opposite side is going to be A, you have a 23. Okay, the opposite side of the B is 11. So this is missing. Okay, and the angle over here is 122. Okay, so you have an angle on opposite side. So that's the indication that you can use the law of a sine law, if you like, because this is going to be 1, and you have this side. So if you use the sine, you can find the B right away. Okay, so let's give you the indication to check what you have or what we can do. So we go with this one. We go with the sine A over A. We can switch it, doesn't matter if you like. You can start with the length divided by the sine, or sine A over A as is in your book. Okay, sine A over A. Then since we have the B, so we go with the sine B over, sine B over B. A substitute. Information that you have is a sine of 122 degrees, and your A is 23. The angle B is missing, sine B divided by the side B, which is going to be 11. The cross multiplying. So the sine of B is going to be this side, is going to be 11. Okay, sine of 122 degrees, and divided by 33. Okay, so use your calculator to get these numbers. Okay, to make sure you get it right. You can check it with your calculator. I just show you my numbers, and we can double check it out, doesn't matter. To get these numbers, see what I have. Okay, I have the angle B is equal to the, sine B. This is what I got. You can double check it with your calculator. It's a 0.4. So I call the sine B equal to the 0.4. and you know that use your calculator, the second operation that you have. I got the B to be equal to, okay, B is equal to the 24 degrees. Okay, you can quickly check with your calculator. You should get almost these numbers. Okay, for this, you got the B. So you have the A and the B, we can find the C. Over here, you got to be careful. You know that sign is going to be positive in the first quadrant and the second quadrant. So you may have a second solution, but you quickly double check to find out. You see this angle is 122. So what we do is we are going to add these two together and you subtract it to get the, okay, to get the angle C. Okay. So the other possibility is, it's not the case for this one, but the other possibility is going to be 180 minus 24, which is going to be a very big one. Because if you add them together, it's going to be over if you like. But when you write it on, you don't need it for this, but you better have a look to make sure you get it all right. Okay, so the angle C is going to be 180, or it's going to be 180 minus the sum of these 222 plus 24, which is quite a lot. So you don't need to check other angle. Okay, so this is going to be 180. 180 minus, okay, 146. 146, there are degrees, of course. So the C is going to be 34 degrees. 34 degrees. Any question? So there is no chance of a second solution because B is 24. Okay, if you add it, as you can see, you get 146 over here. So the other option is going to be 180 minus 24, which is a big one, and you won't get to the second solutions. Okay, so we have the three angles. Now we can go and find the missing side. The missing side is C, so you can go with the A or the B, just using the sine formula. Sine of A over A is equal to this time sine of C over C. Okay, you substitute again, so that gives you the sine of 122 degrees. Okay, divided by 23. Then we go with the sine of C, which is missing. And the length of C is missing, yes. So the sine of C is 34 degrees. That's a 34. And the length is missing. Okay, so this is, I rewrite it. It's a sine of the angle, 34 degrees. Okay, cross multiply again to get it. So the C is going to be equal to, it's 23, the sine of 34, okay, divided by the sine of 122. Again, you have to use your calculator to get it. Check it for yourself, but I have 15. Whatever you need, it's given to you. Again, double check, make sure you get it right. Okay, so this is case one. This case that I gave you was two sides are given to you, okay, and an angle is SSA, we call it, remember? That's case one. Any question? Now, quickly give you the case two. Case two is similar to this one, but that part that I talk about it, you see this B, you may get a second valid solutions to be able, to be able to do it. So in fact, as I told you, the other solution is going to be 180 minus 24. We didn't consider it because that was too much. Are you ready for the next one? So let's see what is special about this case. Number 12, one from each. Information on number 12 is going to be angle A this time is 72 degrees. Okay, the angle A is going to be 72 degrees. And we have two sides as for the other one. We get the A, which is 8.1. Okay, we have the B, which is going to be 8.3. So this is going to be a situation for this one. Okay, so let's try to see. Again, get a graph of your triangle. For example, this is going to be ABC again. So identify the information that we have. We have the A, which is 72. Okay, 72 degrees. Then we have the sides, 8.1. This time we have the B, it's going to be 8.3. Again, the C is missing. It's very much the same problem, but your solution is going to be quite different this time. Okay, there you are. So we have an angle and its opposite side, so we can use the sine formula again. So we use the sine formula. B is given to you. We try to find the, okay, try to find the angle B first, then we go for the C and then we done. Okay, so there you are. So the option is going to be, again, we start with the sine A over A because this 2 is given to you. Okay, that are given. And over here, we go with the sine B. We go with the sine B because the opposite side is given again, 8.3. Oh, I'm sorry. I just write the formula first. It's okay. So I'm going to substitute. So that give me the sine of the 72 degrees, A of 8.1. B is missing, the angle B, but the side B is 8.3. Okay, cross multiply to get the sine B. So the sine B is going to be equal to, is the 8.3, the sine of the 72. Okay, divided by 8.1. Okay, divided by 8.1. Again, use your calculator to get these numbers. Okay, the one that I have is going to be, okay, 8.3 sine of 72. I have 0.97. This is the number that I pick. 0.97. So the sine of B is going to be almost 1.97. Okay, and if you use your calculator, B would be, okay, B would be 76 degrees. That's one solution. Then you check to see if the second solution can be used. You see this is 72. 76, 72 would be almost 140 and 45. So there is a leftover. So we consider the second solution. So what's going to be the second solution? The second solution is another B, which is going to be 180. Okay, 180 minus 76. And this is going to be 104 degrees. You check, you see 104 and 72. And this is going to be, there is a leftover. If you add them together, that give you 100 and, okay. So that give you 170. Okay, that's it. Okay, that's going to be 176. So there is a leftover. So this means you can also have the second one. Okay, so got to be careful. For the other one, it was not possible. So you may get both solutions. So what we're going to do, we are going to call the first one B1. B1 is 76 degrees. Okay, so there is a B2 now. The B2 is going to be 104 degrees. Okay, because there is even when you add it to the A, there is a leftover. So you'll be fine to find the second one, okay? So what we're going to do, we are going to continue with one of them. We pick the B1 equal to the 76 degrees. And now we can find the angle C. Okay, angle C that we call it C1 is going to be 180 minus B1, which is a 76 and 72 here. Okay, 72 and that's it. Yes, we get the 70 to 76. So C1 is going to be 180 minus 148. Okay, 148, and the difference is going to be 32, yes? So that gives you an angle 32 degrees. Okay, any question? So we have the ABC, we have to find the missing part is the side of the C, as we did for the other one. So it's going to be sine A over A equal to sine C over C. So the sine A is the sine of 72 degrees. Okay, 72 degrees divided by A, which is 8.1. And over here, you have the sine of 32 degrees over the side C. Okay, so the C is going to be 8.1. It's 8.1 sine of the 32 divided by the sine of the 72 degrees. Use your calculator. That gives you something like 4.5. Whatever unit is going to be 4.5 inches if you like. Okay, any question? Make sure don't miss the second solution for this one. So we have to start it over and take the B2. B2 equal to the 104 and do the same operation to get the other one. Are you ready? We go with the B2. B2 is going to be 104. So we find the C2. C2 is going to be 180 minus 104 plus the angle A, which is 72 degrees. Okay, so that would give us 180, 176, 76 minus, okay, 76, that give you 4 degrees. So the C2 is going to be 4 degrees. So that's why you have to continue to get these, okay, to get this second solution that we're going to have. Okay, any question? Now we take it here as we did it. Sine A over A. Okay, so the same thing with the angle C2. So you have the sine of 72 degrees divided by 8.1. So now it's going to be the sine of 4 degrees over the C, which is the unknown. So cross multiply, your C is going to be 8.1, the sine of the 4, and divided by the sine of the 72 degrees. If you use your calculator, the length is going to be very small, 0.6 inches, centimeters, one of them. So you got to be careful, just check. You make it 2 solutions, or you may have 1 solution. So you just careful to know to get the proper one in this case. Okay, any question? So these 2 cases was SSA, if you like. We have 2 sides and angle. Okay, in this case, this was the angle. No, it was not between for those. Okay, so let's try number 13. There could be another type that we are. Oh, we just give you these 2. There is another one. They go with the. Okay, there is another case, of course, you have to study these two together. We try to give you one nice application problem, and that was, I give you one problem, remember? I give you the one that we were measuring the length of a mountain. So we are going to create something similar to that because that's a very, very popular case, okay? It's a very popular case. You have a couple of them in your book of this format. I give you this one. So it's very similar, and you will see one of them. Let me explain what is this case. That the case is what they want to do this time is there is going to be a hot balloon instead of the mountain. Okay, this is it. There is a hot balloon here. Okay, that's going to be the balloon. So two friends, they want to measure. Okay, what they want to do is at the same time by they want to measure the they want to measure the height of the balloon. You see, this is going to be the height. They want to measure this one. Okay, this is going to be the h is in question. So what they do is they are going to standing here. You see, one of them is here, and that's the first one. And then in a distance of 2 miles, you see, this is going to be 2 miles. That's a 2 miles, and somebody else looking at the balloon. Okay, so this is the situation that we're going to have. Okay, so there is this is the first person. Okay, the first person, you may call this one A, and you call this one, okay, C, and you may call this one A1. Okay, so what they do, the first one, the angle that he's looking or she's looking is, let's say 10 degrees. And for the second one, the angle, elevation angle, we call it, is 15. Okay, so the angle is going to be 10 and 15. And they are 2 miles apart. So what we'd like to do is we'd like to find the height here. And you know that this triangle is going to be a right triangle. Okay, so read the problem carefully and just get, it's going to be something similar. This is the best problem that you have on those application one. And that give you something. So what we would like to do, we'd like to get this h here. Okay, this h here. So we know that this, you see this triangle, the big one is going to be a right triangle. So it's a right triangle, and this is going to be the height, if you like, or one of the leg. So what we can do is we can, okay, we have this angle. We have the angle 10, and we have the angle 15. So this is, for example, this is angle 10, and this is the opposite side. So since this is opposite sine angle 10, so we can use sine. Remember, the sine is what? The sine of angle is in the right triangle. The sine is going to be the ratio of the opposite side over the hypotenuse. So hypotenuse, if you decided to use the angle 10, so this means you have to find this one. Okay, so if you can find the hypotenuse over here, okay, then you have the angle 10 degrees, and this is going to be your opposite side. Sine of the 10 would be h over whatever it is, then you'll be able to find the h. Okay, so you have two options. You can go with the other one or this one, but this is good because you have this is 2 miles. Okay, you get the 2 miles and you'll be able to find it. Now, this triangle is just the oblique triangle. You don't have right triangle. So we have to use one of our formula to be able to get it. We have the opposite side, which is going to be 2 miles here. Okay, it's the opposite side, which is the 2 miles. So if we have, for example, this angle over here, then we may be able to use Okay, you may be able to use the sign to to get this one. Okay, so what we are going to do is to get this more information. The information is going to be, we do have this angle. You see, because this 15 degrees is 15 degrees, so 180 minus 15. Okay, minus 15, that give you 165. Okay, so that makes this one into the 165 degrees, and easily we can find this one now. Okay, because you need that one to be able to use the opposite side and the angle, use the sine formula to be able. So if you have this angle, you have the angle on the opposite side, and this is a missing one, and then you do have the opposite angle. So application of a sine formula give you this unknown one, and then you be up. Okay, so I'm going to call this one x to know that this is going to be our unknown. Any question? So what's going to be now the angle? This is 165 and this is 10. So the angle B, this B, and the B inside is going to be 180. Okay, 180 minus 165 plus 10. So that gives us 175. So the B would be, B would be 5 degrees. So this angle over here is going to be 5 degree. And now we are ready. We are ready to use the, we are ready to use the sine formula in this triangle to find the x. As soon as we get the x, then we come back to get that big right triangle, and then we be able to find the height quickly. Okay, any question? So now we go for it. Use the this sine formula for here. So I go, so it's going to be sine of 5 degrees. Sine of 5 degrees, the opposite side is 2 miles. Okay, is equal to, the sine of this angle is 165 degrees, and the opposite side is the x, which is the missing line. Okay, cross multiply to get the x. So the x would be what? The x would be 2 times the sine of 165, okay, divided by sine of 5 degrees. Then use your calculator to get this number. Okay, I have something like 5.9, I call it 6. This is 6 mile. Okay, miles. So this is going to be x equal to the 6. Okay. Now I go back to this right triangle and easily I can find the h. Okay, so I have a right triangle here, the big one. I have the right triangle, and I'm just using the sine of the 10 degrees. The sine of the 10 degrees, the sine is the opposite side, h, over the hypotenuse, which is x. And I need h. So I substitute, so it's going to be the sine of the 10. H is missing, the x is 6. So the h would be 6 sine of 10 degrees. And if you use your calculator, it's almost 1 miles. Okay, you can check it out with your calculator. So almost 1 mile. This is going to be the height of the, the height of the balloon, if you like. So it's a nice problem, because you're using all the formulas that we talk about it. So we call it measuring the month and the other night. So this is another one. We give you something similar. So read it carefully. Just make sure that you are able to do it for us as a nice application. Okay, any question? So that's a number 13. So you have a number of the examples on your lecture notes regarding the solving a triangle. You have to read those. Make sure that you are ready for it. Okay. And now there were another case that we can solve. Remember, these are the one that always you have one angle. But the situation is going to be, we may get to the case that no angles would be given to us. Remember, you may begin 3 sides length, and then of course you have to use the cosine formula. So it's very straightforward, you know, we can't miss it. The problem of the cosine angle, okay, cosine formula. So we have it in number 14. The length of the 3 sides would be given, then they ask you to solve a triangle, okay? So the numbers are 5, you can call it 5 inches, you know, whatever you need. You like, B is equal to the 7, and C is equal to 8. Okay, that's going to be the case. So if you graph it, you find out that you don't have any angle. That is going to be A, B, C. Remember, you have to give us a graph of your triangle, label it nicely. And so A, this is going to be 5, B is 7, and the C is 8. So you can use the cosine formula to get the get 2 of these angles, then you'll be able to find the third one. Okay, that's the idea. You can start with either one. If you start with A, remember A squared is going to be the sum of the square of the other 2 sides, if you like. Okay, so you have to B squared plus C squared minus 2BC, the angle, opposite angle. The opposite angle is going to be cosine of A. Okay, opposite of the sides that you start with. That is going to be the case. Okay, trying to see if I can get a better focus of this one. We may lose it, but we may get a better one. Pink. Yeah, that's better. Okay, so this is it. Substitute to get these numbers. You have to solve for the cosine to get this, okay? So we start with the A, which is going to be 25. Okay, 25. And the B is 49. The C squared is 64. It's going to be minus 2BC, 7 times 8. Okay, cosine of A. This is going to be the one that we have. So check right numbers that I have. You simplify it, you solve for cosine, and then you check with your check with your calculator to get these numbers. So I start with the, which one is it? Yes, that's a number 14. Let me check, make sure you get the same number. Put the 15 and yeah, I want to just make sure the final answer that I have. I check it. Okay, so there you are. This is going to be solved for the cosine. So that's going to be 25 equal to, okay, we add these two together, get 113. And this is going to be minus, okay. So it's a 7 times 8, 56. Okay, 112. So that's going to be cosine of A. So the cosine of A is going to be what? Cosine of A is going to be subtract, is going to be 113 minus 25 over 112. Okay, you know that you move this 130 to the other side. You can use your calculator to get the numbers directly. So this is what I have. I have the cosine. It's a 0.785. And the angle is going to be, angle A is 51. And I pick 51.7 degree. You can call it 52, it doesn't matter. Okay, so this is going to be angle A. Okay, so this is angle A. You have to take get one of them, one more. Again, you can pick any you like. I go with the B. So B squared is going to be,
Professor,
yes,
for cosine, I got like 38 degrees.
38. D. 113 minus 25.
I think you did the sine.
I did the sine.
Yeah, possibly.
Okay, how much do you have? Let me check it again for myself. Okay, let's see.
Yeah, the inverse sine of the point
It's 38
equals the
38.3.
Okay, let me check it. 25 divided by
38.3.
So that's a 0.7. That's correct. And then this is going to be cosine inverse of 0.785. Yeah, you are right. 38.2. Yes, 38.2 or 0.3. Thank you. So that's a 38.3.
0.3.
Got it. Okay. Thank you. So check one of them and one more quickly. So we go with the B squared, A squared, C squared minus 2AC cosine of the B. Okay. Now the B squared is going to be 49. The A squared is 25. Okay, it's 25. And the other one is 64 minus 2 times 5 times 8 cosine of the B. Okay, so let's make it into the, it's a 48 equal to, okay, this 2 is going to be 89, and that's a 1080 minus 80 cosine of B. So cosine of B is going to be 89 minus 49 over 80. Okay, so the top would be 40 over 80 almost, which is almost 1/2. So that's easy. And 1/2 is a cosine of 60 degrees. Okay, so that gives us a 60 degrees. Now we are ready to find the C. Okay, so the C is going to be 180 minus these two angles that we have, a 60 plus 38.3. Okay, 38.3. So this is going to be 180. This is minus, okay, 0.389, 98.3. So you're going to be getting a C, which is going to be 7181. I think that's one. You get the you get the third angle, and then we are done. Okay, any question? So that's very easy case, case with the using the cosine formula. So it's straightforward and you can't miss it. But be careful, we talk about it. Sometimes you may not get any solution because this cosine must be between, okay, it must be less than 1. So if we get something otherwise, so just check the solutions, check the examples that we did have on the lecture notes. So make sure you get it right. Okay, so the case of the cosine, very easy. And this is one type. Any question?
No.
Now, we did have a nice formula for the area. So we give you 1 for the area. It's this problem got 2 parts. Okay, for the area. I didn't give you the second formula, but I just want to leave it as is because that give you a chance to apply the cosine formula again. Okay, so this is number 15, the area problem. Okay, we want to find the area. Find the area. And let's go with the part B first. For the part B, it's just that a standard one. You know that you need to have two sides and an angle in between
Yes.
to get that area. So
Mhm.
in this case, this is what we have. You see, this is the A, B, and C. So what we have the angle A, which is 120. Okay, 20 degrees. Then we have the side C is 1 foot. Okay, and we have the side B, which is going to be 4 feet. So that's exactly what we need. We have two sides and angle between. Remember the formula for the area is going to go with the K is 1/2. 1/2 of the product of these two sides, which is given to you. Okay, it's going to be BC. Then the sine of the angle in between, which is the missing one, angle A. Okay, you can put any two sides you like, but this is going to be the angle in between, and this is going to be the missing, missing letters if you like. Now it's straightforward. It's going to be 1/2, and you have the 4 times 1 times the sine of 120 degrees. Okay, so this is it. This is going to be 2 sine of 120. You know that 120 in the second quadrant, and the sine of 120 is the same as the sine of the 60, which is going to be 2 times radical 3 over 2. Okay, and you simplify it, that give you radical 3. K equal to the radical 3, of course, in this case is going to be square feet, because the information are given to you. Is it 2 radical? Yes, it's yeah. Then we simplify. That's correct. Okay, to get these numbers. Any question? That's the case 1. It's straightforward. Now the case 2. I don't want to give you the formula that I told you. There's a formula, we call it Heron formula, but we don't want to use it. We just like you to find it yourself. You see, the case is that 3 sides length are given to you. Want to find it? So this is going to be the case. So that's A, B, C again. Okay, A, B, C. A is 12 meter, or okay, mind whatever. It's a 12. B is 16. B is 16, and the C is 25. Okay. The formula for the Heron formula is this one. But I wanted to use something from tricks. Okay, that's the formula. Let's call it, this is the area. Okay, this is going to be an area. And this is something called it P times P minus A times P minus B times P minus C. And this P is going to be half of the perimeter of the, okay, of a triangle. You see, that's the formula. But if you want to prove this formula, you have to go with the, okay, go with the cosine. The rule of the cosine. In your book, they give you the formula. So suppose you don't want to use that formula to get these numbers. Okay, we let you use it on the test because it is in your book. But the one that I intended really is, you see that what is missing is one of these angles. Because remember, in order to get it, you need 2 sides and angle in between. So it's not difficult to find it. So for example, in this case, if you did have this angle, then we can do it. So what we can do is we can easily use the cosine formula in order to get it. Okay, I prefer this method because this is going to be a squared equal to the b squared plus c squared minus 2bc. Okay, but the cosine of a. Okay, so we find easily angle A, then we come back and we do it. So this is going to be 12 squared, which is 144. B squared is going to be 16 squared, which is 256. C squared is going to be 25 squared, which is going to be 625. Okay, minus 2 times 16 times 25, and then cosine of A. So it's going to be 144. Okay, you add these two together, that give you 81, and minus 800 cosine of A. So we can easily find the cosine of A. So the cosine of A is going to be 1 minus 144 over 800. And if you use your calculator, that give a 0.92. Okay, and I got 23 degrees. I just check it, make sure I did this one all right. Okay, so this is going to be the cosine inverse of 0.92, which is almost 100. I made a mistake over there again. So A is almost 100 degrees. Okay, let me check it again. That was 0.92. And that's the cosine inverse of 0.92. Yes, it's oh, I'm sorry, it's it's 0.99. Yes,
Yes.
0.99. So it's 0.1 almost. Very small angle. For the cosine, yes, because cosine of 0 is 1. So this is very much like that. It's a 0.1. Let's call it 0.1. Okay, 0.1 degrees. Now, you can find the area is going to be 1/2 of the BC times the sine of the 1 degrees. 0.1. Okay, yeah, so we substitute, that's going to be 1/2. 1/2 of the B is 16. Okay, and the C is 25. And this is going to be the sine of 0.1. So this would be 1/8. Okay, so it's going to be 200 times the sine of, okay, sine of 0.1.
Professor,
Yes,
I got 22 degrees on that one, on A.
I have 23 on my notes, but why did I get this one?
No.
88. Let's double check. 88 minus, I have 23 too over here, but I don't know why I got 0.1 here. Let's check it again. This number is correct, 0.92.
Yeah, that's correct. Yes.
Let's check it again. 0.92. No, I won't get this one.
Are you taking the cosine instead of the inverse cosine? Because I got 0.9 for
Let's see,
regular
let's see,
cosine.
let's see, let's see. Maybe that's why. It's a 0.92.
Yes, teacher. 23.
Yeah. My original, on my notes I have 23, but I was, I thought maybe I made a mistake. No, so my solution was correct already. Thank you. So it's a 23. Yeah, I have it with the 23, and the area is 78.1. I thought maybe. So this is the case, okay. So that would be 23, and this is 23. Double check, I have 78. 78.1 something for the okay, for the area. So that give you square meters, you know, or centimeters. So that's going to be no, that's going to be one. It's more interesting than, you know, the Heron formula, because we want to get something, you know, using chats. Yeah, you are right. It's almost 23. So, so this is something better than, you know, because we would like to check this formula rather than, you know, the old-fashioned one. So that is the second part that we did. This is a new, so you better, you know, check it. Just make sure that you are ready for it. Okay, any question?
No.
So I can give a break if we come back and we go over. Oh, let's do 16 too. The new one, 16. Then the rest are going to be the one that we did before. You see, you have to practice, make sure that, you know, you have enough time to do it. I mean, you know, you have to all the lecture time. Now, between the other problems that we did have before, I picked this number 16 because this is the one that we use in calculus, and some people are not familiar with. So I just want to emphasize. It's easy question, but it's very important. Remember the area of a sector of a circle that we did
Yes.
before? That's it. This is going to be the one. So in number 16, you have a circle. The radius is 5 inches. Okay, the radius is 5 inches. And a sector formed by a central angle. That central angle is 25 degrees. The area of a sector is missing. See, that was the one. It used in calculus 1 and calculus 2, this formula. You see, that's going to be the one. Just wanted to remind you that remember this one. So that was the 25, and this is 5. So that's the question, area of this sector. Remember the formula, A is equal to the half of, okay, that was half of the R squared times data. I think that was the one that we did. And the idea was, what was the idea? Idea was, remember we talked about it. This is going to be, if we go around, this is going to be, oh yes, the radian, of course, the radian. This is going to be the radian. So what we did, we find out the area of a full circle. Area of the full circle was pi r squared, okay? And we are interested in this portion only. So this portion happened to be what? This portion happened to be the data in radian. Data in radian would be data over 2 pi. This is the way we proved it. And then we cancel out these two. So that gives you 1/2 of the R squared times the data, but make sure that this data is in radian, okay? So we find this arc length, if you like, to prove it. So make sure your formula is available, and this is the correct one. So your job is, of course, you have to change the 25 degrees into the radian before going in. Okay, so we know that this is the degree equal to the 25. Remember the formula, d over 180 equal to the r over pi. Or in a short version, we don't mind whatever you like to use. Okay, so this is, so we have a 25 over 180 equal to the r pi. You can simplify, then cross multiply it, you see. You can simplify it by 5, so that would be 5. And if you simplify this one by 5, that gives you, I think, 36. Okay, 36 and the r pi. So the r cross multiply would be 5 pi over 36. So that's going to be the data in radian. Data in radian is going to be 5 pi over 36. Now we are going to take it to the formula. So the A is equal to the 1/2 R squared. R is equal to the 5. So 5 squared times 5 pi over 36. Okay, so that gives us A equal to the, it's a 1/2, and we get the 25 times 5 pi over 36. We have to use your calculator to give us the final answer. So A is 125 pi, and that's a 72. Okay. If you use your calculator, the number that I had, just double check it. I should get it right. Number that I put together. Okay, I have 5.45 square inches. Okay, just check to make it sure you get the same number. Okay, 5.45. You have to give us a units, inches, square inches, because the radius was given in inches. Okay, so it's I told you this is something that you got to remember, and it would be important. So why not we give you one of them? We don't need anything else. The arc length it's involved here, so that's why I picked this one. Okay, so that's a new part that you have to refresh your memory. If you need more examples, just your lecture notes and the idea. Be able to do it. Okay, any question? I give you a break. We come back. We quickly go over the rest, which is something familiar from the past, and then we are done. Okay, 16 topics. No surprise. Just these 16 topics. We give you 16 questions. You answer 15 or just a 16 for 150 points. Okay, so see you in about 10 minutes to finish the other parts.
Mhm.
Okay, we're going to look into those problems. Almost all of them are, the one that we did before. Just refreshing your memory. So the question number one is, we give you, of course, one question to graph a function for us. Okay, it's a sine and a cosine, and again, these are the ones that you need for future. So getting back to the question number one. Okay, this is going to be question number one. And we want to sketch the graph of the function, okay? One sine, one cosine, these are the one that we are interested in. And we give you, okay, various methods to do it quickly. So sketch the graph. The first one, y equal to the 3 sine of the 2x. Okay, we want to find the period and the range of the function. So it's a sine function, so the period is going to be 2 pi. The coefficient is 2, so 2 pi over 2, which is equal to the pi. And you know that the range of the function over here is going to be a is equal to the 2, so the range of the function y is going to be equal to between 2 and negative 2. We already talked about the nature of these functions, okay? Because we know what would happen to the sine or the cosine function. So we introduced, that for critical intervals, what we do, we divide the pi by 4 over here. Okay, they give us a pi 4. So in one period between 0 and pi, so you start with the 0, then you go with the pi 4, and then you add it. Then it's a pi 4. Remember, another pi 4 that give a pi half. And you start with the pi half, another pi 4 that give you a 3 pi 4. And with the 3 pi 4, that take you to the pi. This is the one. This method, this is the one that we are interested in, because this would be useful for future application. You can do this type of a segment on your graph, or you just give us these numbers. So what we are going to do is we can locate these numbers for one period. You go in between 0 and pi, so it's going to be 0. And suppose this is, I go with the positive and negative. So I pick this one to be pi. So exactly you divide it by 4 to get those segments here, okay, four parts. So you have to locate these out, these critical numbers for us, okay? So it's going to be pi half, and that's a 3 pi 4. No, the sign start with the origin, because the sign of the 0 is 0. Can go up to the 2 units, go down up to the 2 units, remember? So what we do with the sign is we start with the origin, then we get to the maximum at the first point. Then you go to the intercepts, then you get the minimum for this point, then you go to the back to the intercepts. So this is going to be, okay, this is going to be the graph of this function in one period. Okay, any question? So if it's a negative, you know that you start from the bottom, you go from the bottom, positive from the top. Okay, they
I have a
ask,
question,
yes.
Professor. Is the amplitude 3?
Is it 3? Oh, okay, thank you. 3, yes, thank you. So it's going to be 3. Okay, I call this one 3. So that would be 3. Okay, and they ask for the two. Okay, 2 period. You can go to the right or to the left. Okay, if you go to the left, it's going to be the same thing. Okay, negative pi. You divide it into 4 parts. Okay, and just you continue. So you continue going down here first. Okay, and you go down to your first point. Okay, you go to the intercept in the second one, then you go up to the third one, and this is going to be the graph of your function. Okay, So that's a sine function. Any question? So we give one sine, one cosine. The second one is cosine. Y equal to the, okay, equal to the 2. That's where there are some shifting and those type of ideas, but this method works for all of them. You don't have to worry about, but if you want to shift it, you have to graph the original one first, then the shifting one. You must have both of them on one, one X, Y coordinates, just to show that how they, how they changed. But the same method goes with this one. Okay, so the amplitude is 1/2 over here, the period. This is it, it's going to be 2 pi. Then you have to divide it by 1/2. So that make it to the 4 pi. Okay, so the period is going to be 4 pi. And if you divide it by 4, and that give you pi. So that's 4 units should take you to this one, but you see this is not x, it's something else. Okay, so that's pi in fact. Okay, it's not going to be x, and so you have to, okay, you have to modify it if you like. So the way we do it, you may call this one z altogether, and that z for the cosine must be between 0 and 2 pi all the time. So we have the z 1/2 x plus 3 pi is going to be between 2 pi and 0. Then you solve for x to find out where are going to start to get that period, okay? So the subtracted 3 pi, so that give 1/2 x minus the 2 pi minus 3 pi. Okay, so that give you negative 3 pi less than equal to the 1/2 x, and it's going to be less than equal to the pi. You multiply by 2, so that give you negative 6 pi x, and that would be negative 2 pi. So this would be one period of this graph, okay, between negative 6 pi and the negative 2 pi. But you can bring it into, divide it into 4 parts, and the segment, this is the length of each part. So for example, if you start with the 6 pi and pi, that give you negative 5 pi. Okay, then you have a negative 5 pi, and you add 1 pi, so that give you 4 pi. You see, you should arrive at this one after 4. Okay, negative 4 pi, you add another pi, that give you negative 3 pi, and this is going to be negative 3 pi, that take you to the 2 pi. You see, this method works for all of them. It's such an important techniques for calculus 2 if you want, if you get to that, that part. So this would be one period. So we are going to locate it and graph it. So, and this is it. You want to go with the negative 6 pi and the 2 pi. You can pick something over here. This is going to be between negative 6 pi and the negative 2 pi. We divide into 4 as you predicted. So this is it. That is going to be the 4 that we have. The range is going to be 2 and the negative 2. So this is going to be, okay. That is the range. This is 2. Okay, a equal to 2. So it's going to be 2 and negative 2. So this is it. 2 and negative 2. Okay, now this is cosine. The cosine function is not starting from the origin. It may start from the up, you see over here, or from the bottom one. So this is a situation we're going to have. And the way we are going to go on, so the range is going to be 2 and negative 2. So for this one, right on the top, you see this is it. You have a 2 here. Then we get to the intercepts. Then there is going to be a minimum, okay, at the negative 2. Then you go to the intercepts, and that take you back to the 2 here. So this is going to be the type of the graph that you are going to have. Okay, this is going to be one period of your graph. Any question? Then you can move to the right or to the left. If you want to move to the right, again you are going to see. Okay, you just going to the next part. The difference between these are going to be pi. So that give you, okay, this is going to be 1, 2, 3, 4. Okay, so the action that you are going to have is going to be you continue. Okay, you continue from here. That give you the case. So this is going to be the case. Okay, if you just move on, this is going to be again, you know, pi. It's a negative pi. This is going to be 0. Then we get the pi and the 2 pi. That give you the second period. Okay, any question? So this technique is a nice one and it's used quite a lot in future. So one question, 2 parts. One sine, one cosine. This is going to be just one of them. Would have this coefficient only. The other one would have a kind of shifting. This is the most general one that you have. You have a coefficient over here. So you won't have x and a 2 pi over there. You know, it can be simplified, but we didn't want to do it. You know that 1/2 of the x plus sine x, 3 pi. You pull out the 2 pi, and then it's going to be. Then it can be, you know, it can be simplified with the leftover of the pi, and then to be graphed. But we don't want to do it. Remember, we want to just do it as is. Okay, so that's a question on graphing. Just check, you know, it was in test 2, I think. We did this type of graphing, and we give you one. Question number 2 is just reducing the power, very important procedure in the applications for future. Remember, we give you a formula, we call it reduction of the power formula, or reducing the power formula. So this is going to be the idea for number 2. The reducing power formula was this, that if you have a sine square, for example, and you want to reduce the power into just the sine or the cosine function, no, the first power, if you like. For the first power, for the sine, we go with the 1 minus cosine of the double angle divided by 2. Okay, that would reduce the power of the sine. And if you have a cosine, so the cosine square of x, this is going to be 1 plus cosine of the double angle divided by 2. This is the action for this problem. So whatever angle you have, you double it up. So if we give you 2x, it's going to be 4x to start with. If we give x half, it's going to be x. So be careful for all of them, okay? We did this one before quite a lot, and these problems are just from the past. So I do one of them for you, okay? There are 4 possibilities. Check all of them. I just give you this indication that you'll be ready for it. Okay, I do the second part, which is a little bit different, but you have all of them in your lecture notes, okay? So this is what I'm going to do, starting from, okay, that's to the 4th. We reduce it first because we can do only squares. So that's going to be to the 4th, okay, x half. We reduce it to the cosine square of x half. Everything is squared. That's a step 1. Now for the square, we can do it using the double angle formula. So this is going to be what? 1 minus cosine of the double angle. This is x half, you double it, you get x divided by 2, but all squared. Any question? So that would be step 1. Step 2, square the top and the bottom. The bottom one would be 4. The top is square of the first. 1 square is just 1. Remember, twice of the first times second. 2 times 1, 2 times cosine minus 2 cosine x plus the square of a second one, which is cosine squared. So that would be first step. But you're going to have another cosine square here that you have to take care of it. So the way we do it is we can reduce this one into, you break it, a quarter minus 2 over 4 would be 2. So cosine of x over 2 so far. And this one is going to be a quarter, okay, a quarter of cosine square of x. Now we have to work on this one. Reduce this power. So it's going to be a quarter, okay, minus, if you like, 1/2 of a cosine of x. We get a quarter. Now we take care of this one. Double angle for the cosine, it would be 1 plus cosine of 2x divided by 2. Okay, cosine squared, you reduce it. Now you have to simplify it. It's going to be a quarter minus 1/2 of a cosine of x. This would be 1/8. If you break it, we did before, it's going to be 1/8 plus 1/8 cosine of the 2x. There's always the chance to simplify these two. So that's going to be like 2/8 and 1/8 would be 3/8. So the 3/8 minus 1/2 cosine of x plus 1/8 cosine of 2x. That give you cosine to the 4th of the x-half. You see, the advantage is in this formula, there is no power. You get only the first power of x, and that would be so useful for the operation that we're going to have to in future. Okay, so one of them, sine, cosine, cosine x, sine x. So just be prepared for all. And we have all of them in your lecture note. You can check it. Okay, that's number 2. Any question? No. Number 3, inverse function. We give a collection of these inverse function, and we want you to give us the exact numbers. Okay, again, we did quite a lot, but only one question. So that's number 3. Exact number, exact value. Okay, this means no calculator. Find the exact value of each of these following. There are going to be a couple of them which is a known one, and a couple of them which is unknown. Okay, the first one, you want to find the sine inverse of negative radical 3. You know that this basically means find an angle whose sine is negative radical 3. Now, the operation, remember we switch it first. So you are going to call it theta or just x. So you switch sine x equal to the radical 3. It's like solving the equation, but there is a restriction. Remember, the sine in x here must be between negative pi half and the pi half only. In terms of the sine, negative pi half and the pi. Sine and the tangent, negative pi half and the pi half. Cosine, 0 and pi. Now you pick the the value. It must be in this area. Radical 3/2 is going to be the sine of the 60 degrees. Okay, so x will be equal to the pi third. Make sure when it's a positive. Oh, I'm sorry, I missed something. It's negative. It's going to be positive. It's easy, but the negative one you got to be careful. Okay, so for the positive one is this is where you are. Okay, this is a negative pi half, and the and the pi half. Positive. This is it. So you are going to be in these two portions. The sign is negative, so you are here. So that was for the positive pi third. So you come here and we get the negative pi third, okay? So in this case, x would be negative pi third. Okay, so the sign of the sign inverse of the negative radical that we have is going to be negative pi third. Any question? We know that you see the range is between negative pi half and pi half. So you are going to write it down in negative format, not in positive. We know that this is going to be here, you see. And that is 240 if you like. And this is going to be 300. And your range is between negative pi half and the pi half. Just make sure to pick the numbers, which is going to be in this range, negative pi third. Okay, any question? When it's a positive, it's okay for all of them. When it's a negative, you got to be careful and pick the correct one. Okay, that's a kind of a known one. Part B, something unknown. It takes a little bit more time. The cosine of the sine inverse. Okay, sine inverse of the 3/5. So we start from inside. Okay, we call this one x. So it's a sine inverse of 3/5 equal to the x. So quickly that gives you sine x equal to the 3/5. So now this means just a cosine x. Okay, this means only cosine x. So the cosine, the sine inverse of the 3/5 is just cosine x, which is missing. So you are going to use this, you know that the right triangle, when it's a positive, we don't have anything to worry about. So this is going to be your angle x. You have the sine. Okay, the sine is going to be the opposite side and the hypotenuse. And this is going to be 4. And you want to find the cosine. So the cosine x is equal to the adjacent one, 4/5. Okay, so the cosine of the, so the answer is 4/5. The cosine of the sine inverse of the 3/5 is just 4/5. Okay, any question? So it's going to be now, we give you some nice number to be able to do it quickly. The other one is over here, we have a tangent. Okay, of the cosine inverse of negative 3/5 now. When it's a negative, you got to be careful. Okay, the first step, cosine inverse of negative 3/5. You call it x. Cosine of x is negative 3/5. You know that the x is between 0 and pi this time for the cosine. Okay, so we get the right triangle. So x is going to be in the second quadrant in this case. Okay, so you get the right triangle to get it. Okay, this is going to be your x. Okay, this is going to be x, and the cosine, adjacent one, 3 or negative 3, doesn't matter. And this is 5. So this is going to be 4. You are interested in tangent, because if you substitute, then give you tangent. So the question is, what's going to be the tangent of x? Okay, since the cosine is negative, you make sure that you know that the tangent is going to be negative. Okay, so tangent of x is negative, and you read it from this triangle. So it's going to be minus, okay, the opposite over the adjacent. So negative 4/3 is going to be the final answer. Okay, any question? So just don't miss those negative, positive signs. Again, we did quite a lot in test 2, I think. Those inverse trigonometric function, or test 3. Okay, any question? So that's a part C, and you have one more, and you know it's probably the same question or similar one to the one that we did before. Just give you the indication that which section are going to go back and refresh your memory. So the next one is cosine inverse of the cosine of the 7 pi 6. Some people quickly, they answer this one as a 7 pi 6, not all the time, because this is a kind of opposite operation. You see, cosine inverse of the cosine. Cosine inverse of the cosine of an angle must be angle. But you got to be careful because of these different, because this limit or the range that we're going to have. So you got to be patient to get this one first. Okay, cosine of 7 pi 6. Okay, is equal to 7 pi 6 is what? 210. 210. You can go and find it. It's like the 30 degrees, but it's going to be negative. So this is it. Okay, negative radical 3 half. So you go there now. So the question is going to be, what is cosine inverse of, okay, cosine inverse of negative radical 3. That is going to be the case. This is tricky now. So you are going to call it x. You call it x. So the cosine x is equal to the negative radical 3 half. Quickly, you write the condition. Condition is x must be between 0 and pi. Means this x is in the second quadrant. Okay, second quadrant, radical 3 half is going to be
By 6.
So this is going to be cosine. The positive one is cosine of the 30 degrees. So 5 by 6 is the answer. Okay. So x is equal to 5 by 6. So the cosine inverse of the cosine of the 7 by 6 is 5 by 6. If this angle is going to be in the first quadrant, okay, and this is going to be just true. You see, cosine inverse of the cosine of the pi 4 is pi 4. Cosine inverse of the cosine of the pi 6 is pi 6. But when it's a negative, then you'll be in trouble. They give you 7 pi 6. So be careful. You better check it. Don't memorize any formula. So it may come with the tangent or may come with the cosine. It's not going to be coming with the sine. So be careful. You know, just try it. So one question on the inverse function. This is going to be one. Now, we have lots of formulas for the 3 categories we are interested in. See, double angle, half angle, and the sum on the difference. We are not going to give it like the one we did before. We just give you one question, but we just ask a couple of these. Okay, I just put the sign, a couple of them here. Just we may change it. This is sine, we may change it to the cosine. So be prepared for it, okay? But otherwise, just wanted to remember, you know, these formulas. So what we have, the information would be given to, we have the sine of the alpha. Sine of the alpha is, this would be a little bit more, takes a little bit more time, okay, to finish it, but not bad. It's an alpha between 3 pi half and the 2 pi half. We have the sine of the beta. Sine of the beta is 4/5, and the beta is in the second quadrant. Okay, quickly find the cosine of both of them because you need it. Okay, you need it in this problem. So before going on, we just taking care of that one first. And so this is the sine of alpha, which is negative 12/13. Okay, so get the right triangle. So this is going to be alpha. So we have the sign, so 12 or negative 12 over 13. So this would be what? 160, I think that's 5, yes? 169 minus 144.
Mhm.
Okay, that's one. Okay, so we can find the cosine. We are in a, okay, we
In
are
the
on the
square.
fourth quadrant. So the cosine is
In
positive.
the fourth, yes.
Okay, it's going to be positive. It's going to be 5 over 13. Okay, 5 over 13, that's cosine. We do the other one too. We have the sine of the beta, which is 4/5. Okay, this is it. This is going to be beta. We have the sine, and this is going to be sine. So this would be 3. Okay, this would be 3, and the beta is where? Is in the second quadrant. Second quadrant, cosine is negative. Cosine of the beta is going to be negative, and that gives us 3/5. Okay, you need to collect this information for this problem first, and then one by one. Bring the formula and just get the result. Part 1.
Mhm.
Sine of the double angle, sine of 2 alpha. You know that the sine of 2 alpha is what? Is 2 sine alpha,
Sine alpha to cosine.
cosine alpha. Substitute. It's going to be 2 times. The sine of the alpha is negative 12/13. And the cosine of alpha is 5/13. Okay, that's it. It's 5/10 is going to be sine of 2 alpha is going to be negative 120 over 169. That's it. You cannot simplify it and that final answer. Okay, any question? So just make sure use the proper formula. This is sine of 2 alpha. Make sure that you remember cosine of 2 alpha. Remember cosine of the double angle is, for example, 2 cosine square minus 1, 1 minus sine square. So bring those formulas ready to be able to apply it. That's case 1. So one of these double angle, sine or cosine. The other part is one of these difference or the sum of 2 angles. I just put the sign of alpha minus beta to remind you. We may give you cosine alpha minus beta, or may give you cosine of alpha plus beta. So be ready for it. The formula is the sine alpha cosine beta minus cosine alpha sine beta. That's it. And we already got all those information. We substitute. The sine of alpha is negative 12 over 13. Okay, cosine of the beta is negative 3 over 5. Minus cosine of alpha is 5 over 13. And the sine of the beta is 4/5. Okay, so this is going to be 36 over 65. And it's going to be minus 20 over 65. Okay, 36. So this is going to be 16 over 65. That's it. So the sine of alpha minus beta is going to be 16 over 65. Okay, that's it, part B. Any question? So that's the second category. The third one is half angle.
Mhm.
Either cosine or sine. So I want cosine of the beta half. We can check the sine of the beta. Both of them are the same. Now the way we do it, remember, we use the square first for the double angle formula, then we come back. So this is the way I do it. I go with the cosine square of the beta half. Remember, I reduce it. 1 minus cosine of double angle would be beta over 2. If they ask for the sine, this is going to be 1 plus. Now I have the cosine of the beta. This is it. 1 minus cosine of the beta was a negative 3/2. Negative 3/2, negative 3/5, sorry. Divided by 2. Simplify it. So that gives 1 plus 3/5 over 2. 1 plus 3/5 would be 8/5. So we continue on the top would be 8/5 divided by 2. Okay, so it's going to be 8/5 times the reciprocal of the 1, which is a half. And you simplify it, that give you 4/5. Okay, so the cosine square of the beta half is 4/5. Now you take the square root. So the cosine of the beta half square root would be positive negative radical 4/5. So we take the square on the top and the bottom. On the top give us 2. On the bottom radical 5. You can leave it or just it's like 2 radical 5 over 5. Now the question is which one? Positive or negative? You go back and look at the beta. Beta is given to is between pi half is in the second quadrant. Okay, but you want the beta half. So you divide it by 2, that give you pi 4. Okay, beta, and they give you pi half. Beta half. So your beta half would be in the first quadrant. In the first quadrant, this means cosine of the beta half is positive. So your answer must be the positive part, 2 radical 5 over 5. Make sure you check it. Okay, any question? Some people go with that radical right at the beginning. We don't mind, but that's easier. Okay, if it gave you sine square, it's going to be 1 plus. So stay with a square first. Okay, simplify it, take the square root. Make sure you use the positive and negative. Then decide. You go back to see what you have. Whatever you have, you divide everything by 2. You divide everything by 2, you identify the position of the beta half. It's going to be either positive or negative, then pick the correct answer. And that give you the 1. Okay, any question? So check the other similar formulas, sine of the pi half. Those make sure you are ready for it. Okay, so that is number 4. And category number 4 that we're going to have. And number 5 is, that this is complex numbers. We did it several times, so we want to check it again. Operation with the complex numbers, ordinary operation, nothing else, okay? So it's just adding, subtracting, multiplying. So part 1, it's 4 plus 3i minus 2 times negative 3 minus 5i. It's like in algebra, you distribute it, you combine the like terms. If you get to the I squared, you replace it by negative 1. So in this case, the distribution would be the first one, just open up the parentheses, remove it. The second one, carefully multiply. Negative 2 times negative 3 would be a positive 6, and this would be a 10. 10i. Combine the like terms, start with the number reals. 4 and 6 would be 10, and that would be 13i. That would be the final answer. Okay, nothing difficult about it. Any question? Just give you a couple of them, but the division is going to be one of them, of course. Now, the next one is a multiplication, 5 minus 2i times negative 3 plus I. Okay, we FOIL it. So we FOIL it, that give a negative 15. We move forward, plus 5i. and over here is going to be plus 6i, negative positive would be negative 2i squared. Now combine the like terms first, negative 15, 5i and the 6i would be 11i, but I squared is negative 1. So you change this sign into the positive 2. Okay, remember I squared is negative 1. Then you continue with simplification, negative 15 and 2 would be negative 13. Negative 13 plus 11i is the final answer. Any question? Just, FOIL method, just don't miss any signs. Now, the big one is the division. You know that. This is going to be 1 plus 2i. 1 plus 2i over 3 minus 4i. You know that. We have to change the denominator, realize the denominator. We multiply the top and the bottom by the conjugate of the denominator. Conjugate, this is 3 minus 4i. You multiply by 3 plus 4i. So we have to rewrite it. It's going to be 1 plus 2i, and that's a 3 minus 4i, which is equal to, so that's a 1 plus 2i. Remember, conjugate of the bottom one, it's a 3 plus 4i. And the bottom one is 3 minus 4i. You multiply by 3 plus 4i. Okay, you have to distribute the top and the bottom. The bottom one is a special product. 3 times 3, 9. Minus 4i times 4i, 16i squared. Distribute the top, multiply the 1 and just go forward, 3 plus 4i. Then multiply 2i, that gives you 6i plus 8i squared. Combine the like terms. The top, this is 3. 4i and the 6i would be 10i. I squared, remember negative 1, so that make it into the negative 8. The bottom one, 9 minus 16i squared is negative 1, make this one into the positive 16. Continue on the top. 3 minus 8 is a negative 5 plus 10i. And this is going to be 25. You're not done. You have to break it, write it down as a number, complex numbers. 5 over 25 plus 10 over 25i. Now we get a chance to simplify it. So that will be negative 1/5 plus 2/5 I. The final answer. See, this is the way you simplify it to get these numbers. That's it. We get the 6, 7. We did it before. So 16 question, and you should be able to do it in. We give you time, your lecture time. You should be able to do it, at. So study these, and just if you need more examples, just check from your lecture notes, especially those new one triangles, finding the roots. Make sure you don't miss it. Otherwise, it's not. There's no surprise. It's going to be the one. That's it. Yes, question.
Teacher, can I ask a question?
Yes, what's the question?
About the half angle, about cosine exponent 2, the half angle.
Yes.
It should be 1 plus cosine double angle over 2 or 1 minus.
Oh, we missed that. It's too late.
It is 1 plus.
Yes, I know what you mean. Yes.
You said 1 minus.
Yes, I made a mistake. It's too late.
Yes,
okay.
and
okay, I'm going to go. Okay, let me correct it.
And also you have another when you rewrite cosine, the second question also.
Second question?
Yes, about sine square or cosine square x half.
No, I did it all right there.
Yes, this is here, teacher. B, number B.
Oh, it's too late. Okay,
Yes,
so what?
you make one
Okay,
minus cosine. It should be 1 plus cosine.
okay. What
Yes.
I can do is I can change this one into the sine to the fourth of the x half.
Oh, yes. It's okay.
Then
No.
it would be all
Yes.
right. But anyway, you can change it.
Yes.
But I'm sorry about that.
Mhm.
So this is going to be sine to the fourth of x half, which is equal to the sine square of the x half, all squared, okay? So
Yes.
this would be true for the sine. I want to give
Mhm.
you this one on the final, so I have to switch that one.
Yeah.
Okay, so that's going to be the one. So yes, it's a sine square. And then you change that one yourself, you are right.
Mhm.
That's when I double check it. Okay, anything else? Yes, you can bring the formulas, we don't mind.
Mhm.
You can, yeah, you can bring lots of formulas. Yeah, you can make a one-page note, something for yourself. Make sure that, because there are quite a lot, make sure that all your formulas are ready so that we are not going to make any mistake. Okay, so that was one. Anything else?
Yes. About the quiz, teacher, the third quiz,
The third quiz,
we didn't get our grade.
the third one,
Yes.
you didn't get your grade. I think I'll check your grades and give you a point. I think I graded the quiz number 3 for the other people.
Mm, I don't have it. I didn't
You don't have it. Okay, okay. I love, I have time. Let me finish this one first, then I'll go and check all your grades
Thank you.
because I'm going to drop the your lowest quiz and the lowest test.
Mhm.
So what I would do usually is the big one, your best one, I call it test 1 and test 2. Okay, so when you go back and have a look, because I put the bad one as test 3 and I drop it, it's going to be the same for your quiz. So just give me a couple of days, then you check. If then anything is missing, just let me know. Okay, so your lowest quiz and the lowest test would be dropped. So on the final part of the grade book that you're going to get your points, you have a category of the test 1, test 2, this is going to be your best 2. And if you see the test 3, you can ignore it because it's not going to be the way I'm going to do it. I'm not going to consider the others in your, your average or your final course grade. So I'll double check everything before your final. If I need, then I email you. But I think you said quiz 3. I know the test 3, I haven't graded yours.
Yeah.
But I should check the quiz 3 too. Okay, I'll check it.
Yeah.
Okay, that's going to be one. Anybody else?
Thank you.
If you have any missing point, missing grades, email me.
Mhm.
Let
Thank you.
let me finish that test 3. It's 2 questions. I'll do it tonight. Then if there's anything missing, let me know so that before final we have all these okay points and the grades in one place. So we get the numbers for you. Okay, this is going to be one. I check your homework. If you submit it on the canvas, you will get your points. Otherwise, we will see what will happen to your homework. Okay, let me check it. Lindsay, you emailed me quite a lot. Okay. So I'll check it. Okay, I think I gave you one. Okay, I checked that one.
Mhm.
Yeah, okay. Okay, any more question, anything?
No.
That's it. Good luck. You already done a good job. Nothing to
Thank
worry
you.
about really. Just
Thank you,
keep up,
teacher.
study, no surprise. Study these 60 topics and
Mhm.
you should be fine. Why not? And if you
Mhm.
have any question, anything, you can email me
Thank you,
before the final.
teacher.
Otherwise, the final is just the class hours, if you like. It's like the class, you come 6 to 9. We give you all the times you need. to be able to finish it. Okay.
Uh-huh.
Next
Yes.
Tuesday, don't be late.
Thank you.
Okay, have a good one.
Thank you.
Bye bye.
Same to
Take
you.
care.
Thank you. Have a great
Take care.
day. Thank you.